Hello everyone, welcome back to my channel Gems of Knowledge. So in today's video we are going to deal with the continuation part of the exercise 12.5, that is from the chapter circles of class 9th. Okay, so before starting the video, you know the drill. Make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new video. So here the next question you can see, ABCD is a quadrilateral whose diagonals intersect at a point E. So this ABCD is a is a quadrilateral whose diagonals, these are the two diagonals which are intersecting at a point E. If DBC is equals to 70 degree, you can see this is DB and C, this angle is 70 degree, and BAC, this angle is 30 degree. You can see BAC, this angle is 30 degree. Find BCD. Okay, this is the first question. You need to find BCD. This whole angle you need to find out. Okay, in the further case, if AB is equals to BC, then that is this AB is equals to this side is equals to this side, then we need to find ECD. Only this part of the angle we need to find out. Okay, so let us write what is given first. Given two angles are given, as you can see, DBC is equals to 70 degree is given and BAC is equals to 30 degree is already given. Okay, then what we need to find to prove, we need to find what is the value of BCD. Angle BCD is equals to question mark, and in the further case we need to find what is the value of ECD also. Okay, two things we need to find here. Okay, so then in the proof we will start. We know that ABCD is a quadrilateral. Okay, so in the quadrilateral they have already told us this is 70 degree and this is 30 degree. Okay, we need to find this complete angle. Okay, so here already they have given this angle is DBC is 70 degree. If this is 70 degree, what will be this angle? Okay, that is, we can write DBC is equals to DAC. DAC both are equals to 70 degree since angles in the same segment. Angles in the same segment. Okay, these are the two angles which are similar, because if this is 70 degree, this is also 70 degree. Okay, then if you got this angle to be as 70 degree, then what we will do is we will add this angle DAB. Okay, total angle DAB is equals to, this DAB is divided into two parts, as you can see, DAC and CAB. Okay, so DAB plus CAB. DAB we are having, sorry, DAC. Okay, this is DAC. This is 70 degree plus CAB is 30 degree. So it is totally of 100 degree. Okay, this we got it as 100 degree. Now we know that ABCD is a quadrilateral. If ABCD is a quadrilateral, in a quadrilateral, we know that opposite angles will be equal to 180 degree. So we can write DAB plus DCB, that is DAB plus DCB together is equals to 180 degree. We know that DAB is already 100 degree. Just now we got here DAB is equals to 100 degree. This is 100 degree plus DCB is equals to 180 degree. So what happens here is we will keep this DCB as it is. We will bring this 100 degree to this side. It will become 180 minus 100, which is equals to 100 degree. Okay, which is equals to 80 degree. Sorry. Okay, so 180 minus 100 is 80 degree. Okay, so this complete angle we know that it is 180 degree. That's what we needed. BCD, angle BCD is equals to 80 degree we got. Okay, one thing we got. Now in the second part they have told us, if AB is equals to BC, if AB means this side is equals to this side, then we need to prove what is this angle. Okay, so if you consider this triangle ABC, we know that if two sides are equal, then that particular triangle is known as isosceles triangle. Okay, so if two sides are equal in that angle, in that particular triangle, then two angles are also equal. So this angle will be equal to the same thing, that is 30 degree. Okay, so let us write. Consider the triangle. Consider triangle ABC. If AB is equals to CB or BC, then BAC, angle BAC is equals to BCA together is equals to 30 degree, since isosceles triangle. Okay, since it is isosceles triangle. Okay, now as we know this is 30 degree, we need to find out this value. So together we know this is equals to 80 degree. As you can see, angle BCD is equals to 80 degree we came to know. We need to find the value of ECD. Now let us write BCD. Angle BCD is divided into two parts, that is BCE. You can see into the figure, BCE plus DCE. Okay, so we know that BCD is equals to 80 degree, which is equals to, this way got it as 30 degree plus DCE. So DCE is equals to, we will keep DCE as it is here only, we will move this to this side. So it will become 80 degree minus 30 degree, which is equals to 50 degree. Therefore, we got the value of ECD, which we needed here, ECD. Okay, you can see this value is equals to ECD or DCE. This is one and the same. We got it to be as 50 degree. Okay, so this is the answer here for the sixth one. We'll move on to the next question. Okay, so you can see, if diagonals of a cyclic quadrilateral are diameters of the circle. Now you can see a circle, okay, and you can also see the diagonals here. This AC and BD are the two diagonals of this cyclic quadrilateral, okay, through the vertices of the quadrilateral. So from the vertices, it is the diagonal of a cyclic quadrilateral. Then what we should prove here? We should prove that it is a rectangle. This ABCD is a rectangle. We should prove that. Okay, so they have given in the given things, what they have given, AB is equals to AC is equals to BD, which are the diagonals of cyclic quadrilateral. Okay, cyclic quadrilateral, or you can also say that they are the diameters of a circle. They are the diameter of the circle. You can also write this, that AC is equals to BD is the diameter of the circle. Okay, then what we need to prove? To prove that ABCD is a rectangle. Okay, so in proof what we will write? Consider AC is a diagonal. First we will consider that AC is a, sorry, not diagonal, AC is a diameter. Okay, if AC is a diameter, then we can write this angle D is equal to this angle B. Angle D is equals to angle B is equals to 90 degree. If this is a diameter of the circle, then easily we can say this angle is 90 degree and this angle is 90 degree, since angles in the semicircle. Okay, so you can see, if you cut this from here, this is half portion of the circle and the upper part is the half portion of the circle, which is also known as semicircle. Okay, so this is like this. Okay, then now if we consider BD is a diameter, if BD is a diameter, then we can say that angle A is equals to angle C is equals to 90 degree, since the same reason, that is angles in the semicircle. Okay, now if we consider both the equations, we'll consider this as equation 1 and this as equation 2. Now from equation 1 and 2, we can write that From equation 1 and 2, angle A is equals to angle B is equals to angle C is equals to angle D. All the four angles are equal to 90 degree. Therefore, we can say that ABCD is a rectangle. Okay. To the next question, if the non-parallel sides of a trapezium are equal, as you can see, non-parallel sides, so we know that AB is equals to CD, this is the parallel side, and the non-parallel sides are this, that is CB and AD. These are non-parallel sides of the trapezium. If suppose that non-parallel sides of trapeziums are equal, we need to prove that it is cyclic. We need to show that this figure is cyclic. Okay, so first for that we will write what is given. Okay, so given things, ABCD is a trapezium. ABCD is a trapezium. Okay, and we also know that this DC is parallel to AB. Already we know that. Okay, and now according to the question, they are also telling us that AD is equals to BC. This AD is equals to this BC. They are also telling us that this AD is equals to this BC. See, you can see non-parallel sides of the trapezium are equal. Okay. Then to prove, we need to prove that ABCD is a cyclic quadrilateral. ABCD is cyclic quadrilateral. Okay. Now proof. We will consider, we know that ABCD is a trapezium. Okay, so if it is a trapezium, we know that the adjacent sides, sum of adjacent sides is equals to 180 degree. If it is a trapezium, this side and this side, or we can say this and this side, whatever two sides, but side by side two angles will be equal to 180 degree. So we know that we will write angle A plus angle D is equals to 180 degree. Sum of two angles is equals to 180 degree. We'll keep this is equation 1. Similarly, we may write angle B and angle C plus angle C is equals to 180 degree. We'll keep this as equation 2. Okay. Then from equation 1 and 2, we can write that angle A plus D plus angle B plus angle C, all the angles 1, 2, 3 and 4 angles will be together is equals to 180 degree plus 180 degree, which is equals to 180 plus 180 is 360 degree. So this figure, if it is totally equal to 360 degree, then we can say that this is a cyclic quadrilateral. Therefore, we can directly write ABCD is a cyclic quadrilateral. Okay, we'll move on to the next question. Okay, next question, as you can see, ninth one. Two circles intersect at 2 points B and C. These are the two circles which are intersecting at a point B and C. Through B, two line segments ABD. From B, two line segments are passing. As you can see, ABD, one line segments, and PBQ, second line segments. To intersect the circles at AD, these two line segments are intersecting these circles at the vertices, that is A, D here, and P and Q respectively. We need to prove that ACP, you can see ACP, this angle, okay, this angle is equals to QCD. This angle we need to prove. Okay, so for that, first we will show that this angle is equal to this angle. Okay, since vertically opposite angles. So which is this angle? ABP. Okay, so directly we'll write with the proof. You know what is given and what is you need to prove. You know that. Directly I will start with the proof here. So first thing what we will write is ABP. Okay, ABP is equals to QBD. Equation 1 we will write The reason for this is vertically opposite angles. As you know, as you can see, this is the center point and this is opposite angle to this. So both are vertically opposite angles. Okay. Now we can say this angle is equal to this angle. Okay. That is ABP. As you can see, ABP, angle ABP is equals to this ABP. This angle is equal to this angle, that is ACP. Okay, equation 2, since angles in the same segment, okay, both are the angles in the same segment, as this is the circle here. Okay, so this is like this angle and this is this angle within this bigger circle. So these are the two angles in the same segment. Similarly, here you can write for the smaller one, this angle is equal to this angle, that is angle QDB, angle QBD is equals to angle QCD. This is equation 3. Again the same, since angles in the same segment. Okay. So now as you can see, QBD is equals to ABP. Already given, QBD is equals to ABP. Now this ABP is equals to ACP. So directly you can write QBD is equals to ACP. Okay, from equation 1, 2 and 3. Therefore, hence the proof. We needed only these things, okay, which is already done within this 3 equations. Okay, we'll move on to the next. Next question, you can see, if circles are drawn taking two sides of the triangle as diameters. Okay, so now these are the two circles. Okay, and these circles are intersecting at 2 points, that is P and S. Okay, the circles centers are A and B, but they have taken one triangle. Okay, and that triangle, two sides of the triangle are the diameter of these circles. Thus, we need to prove that the point of intersection of the circle lie on the third side. So these point of intersection S lie on the third side. We need to prove that. Okay, so a small construction we have done here, that is we have joined, you can see the dotted line which is shown here. We have joined P and S. We need to join this P and S. Okay, so now we'll start with the proof. As you can see, we will consider PAQ as diameter. Okay, if this is the diameter, then we can write this angle is equals to 90 degree, that is PSQ, angle PSQ is equals to 90 degree, since angle in the semicircle. Okay, similarly we can write, if PBR is diameter, then this side we can write, that is PSR, angle PSR is equals to 90 degree. Again the same reason we can give angles in the semicircle. Okay, the same reason, that is angle in the semicircle. Now if we see this QSR, angle QSR is equals to this things you can write, that is PSQ plus PSR, which is equals to 90 degree plus 90 degree equals to 180 degree. If this is 180 degree, then we can write QSR, angle QSR is a straight line. Okay, straight angle we will write. Okay, as you can see, this is a straight angle, 180 degree, totally it is of 180 degree, that means this is a straight angle. So if it is a straight angle, we can say that QSR, this line segment, is a straight line. Okay, this is a straight line, therefore we can say that point S is on the third side of triangle PQR. Okay, Okay, next question you can see ABC and ADC are two right angle triangles. You can see ABC and ADC together are the two right angle triangles with a common hypotenuse. This is the common hypotenuse for both the triangles. We should prove that CAD is equals to CBD. Angle CAD. This angle CAD is equals to CBD. Okay, we need to show that. So what we will do is we will start with the proof. Okay, so in the proof we will consider in triangle ABC. First we will consider the triangle ABC wherein angle B is equals to 90 degree. As you can see, this angle B is equals to 90 degree. Already we know that. Okay, so what we will do here is next we are having, okay, if this angle is 90 degree, we know that in a triangle, the completely three angles, sum of all the three angles will be equal to 180 degree. We know that. But this angle alone is only 90 degree. That means what about the other two angles? It is also equal to 90 degree. So what we will write is BAC, angle BAC plus BCA plus BCA together it is equals to 90 degree. We'll keep this as equation 1. Now we'll consider another triangle, that is ADC. In triangle ADC, angle D is equals to 90 degree. Already we know angle D is equals to 90 degree. Okay, then the remaining two angles will be equals to 90 degree. That is DCA, angle DCA plus angle DAC together will be equals to 90 degree. This is equation 2. Now adding equation 1 and 2, okay, adding 1 and 2, what we will get is angle BAC plus BCA, okay, plus DCA, the left side whatever are there we have to add that. This DCA plus DAC together is equals to 90 plus 90. Okay, so you can see angle A and angle A, we will bring this closer, that is angle BAC plus DAC will bring this closer, and this two we will keep it closer, that is BCA plus DCA we will keep closer, which is equals to 90 plus 90 is 180 degree. Now as you can see BAC plus DAC, BAC plus DAC together we will get angle A. So this is together angle A plus this is together angle C. Both are equals to 180 degree. If these two are 180 degree, it means opposite angles of the quadrilateral are supplementary. 180 degree means we can say that opposite angles, sum of, okay, sum of opposite angles of quadrilateral are supplementary. Supplementary means it is equals to 180 degree. If it is supplementary, therefore we can say that both are CAD is equals to CBD. Both are, therefore we can say that it is a cyclic quadrilateral. Okay, this ABCD is a cyclic quadrilateral. Now if it is cyclic quadrilateral, then we can easily say that CAD, angle CAD is equals to CBD, since these are the angles in the same segment. Since angles in the same segment. Okay, so the question is, prove that a cyclic parallelogram is a rectangle. We should show that this cyclic parallelogram is a rectangle. Okay, so directly they have given this figure is a cyclic parallelogram. So if it is cyclic parallelogram, okay, what we know that if it is cyclic parallelogram, we know that in case of parallelogram opposite sides are equal. So we can write AB is equals to DC. AB is parallel. You can see these two sides are parallel. AB is equals to DC and AD is parallel to BC. This AD is parallel to this BC. Okay, and we also know that angle A is equals to angle C. That is opposite sides are equal. Since opposite sides are equal in parallelogram, since opposite sides are equal in parallelogram. Okay, then we also know that opposite angles, sum of the opposite angles, that is angle A plus angle C is equals to 180 degree. Since opposite angles of cyclic parallelogram, cyclic quadrilateral. Okay, so in case of cyclic quadrilateral, we know that angle A plus angle C, sum of the two opposite angles will be equals to 180 degree. Now since this one, as you can see here, angle A is equals to angle C. So in place of angle A or in place of angle C, we can write angle A plus angle A. In place of C, we will write angle A, that is because both are equal, which is equals to 180 degree. So angle A plus angle A is 2 times angle A is equals to 180 degree. Therefore angle A is equals to 180 by 2, that is 2 ones are 2 nines are 18 and 0. So angle A is equals to 90 degree. So therefore we can say that this cyclic parallelogram is a rectangle. Therefore the given cyclic parallelogram is a rectangle. Okay, so that's all for today. This chapter is completed. So I hope you have understood with this exercise also. So if you are having any doubts, you can comment me down below. So I'll be back soon with another video on another chapter. So till then, stay tuned and stay connected. Thank you.